In this video, we're going to talk about how to add vectors graphically. So, what exactly a vector is? Now, we know that a vector quantity is any number or any value that have both magnitude and direction. So, when you have a data that have a numerical value and a direction such as your north, south, and east, those are actually example of your vector quantity. Now, if you don't know yet what a vector quantity is, you can actually check on the description below for some another video tutorial. So now let's talk about how to add vectors. Now, the first thing I want you to know is to understand your Cartesian plane. So let's try to have a Cartesian plane here. So this is actually an example of Cartesian plane, and we should know that this should be our x-axis and this is your y-axis, as well as this your north, south, west, and east. Now I also want you to know that this is our first quadrant, second quadrant, third quadrant, and fourth quadrant. Now for your first quadrant, your x and y here are both positive. Now for your second quadrant, our x and y here are positive and negative. Now for our third quadrant, I also want you to remember that your x and y here are both negative. Now for fourth quadrant, I also want you to know that your x and y here are positive and negative. Now I want you to keep this in mind because this is really helpful in adding vectors graphically. So let's try to have some example of vectors and let's try to graph it. For example, we have your vector A and your vector B. And your vector A has this value and your vector V or B has this value. Now, how are we going to add these vectors and draw the resultant vector? Now, basically, we can actually use two ways to add these two vectors. We could do the head to tail method or we can do the parallelogram method. But let us try first how to do your head to tail method. Now the idea behind here is to add these vectors from the head of the first vector to the tail of the next vector. So for example, our first vector is actually vector A, and this is actually our central axis. Now first thing to do is to draw the first vector from the central axis, like this one. Then this will be our vector A. Now I want you also to remember that this is the head of your vector and this is the tail of your vector. Now the second thing to do is to add the second vector, which is your vector V, starting from the head of your vector A. So let's try to do it. So this is how should we draw the vector B. We know we draw it starting from the head of your vector A. So that is why called head to tail, because we are going to add two vectors starting from the head of the first vector, adding it to the tail of the next vector. Now how about the resultant vector? Now for the resultant of vector, we are just going to simply draw a straight line from the central axis, which is here, to the head of the last vector, which is here. Now let's try to do that. So this will be our resultant vector. Now we should know that R, or the resultant, is actually A plus B. Why? Because again, this is your x vector or x-axis and this is your y-axis. So basically your vector A is written respectively with your x-axis. So your A is actually your x-axis and your B is your y-axis because it is drawn with respect to your y-axis. And we all know that this vector A and vector B are directed to the positive side. So that is how we do it. Now let's try to have our parallelogram method. Now the idea behind here is not to add vectors from the head to tail, but to draw all the vectors from the central axis. Now let's try to do it. Now we know that this is our central axis here. And the first thing to do is to draw the first vector starting from your central axis. So now let's try to graph or to draw the first vector. Then this is how we do it. So this is our first or A vector. Now the second thing to do is to also draw the second vector, but from not the head of your first vector, but from the central axis of your Cartesian plane. Now let's try to do it. Now this should be our vector B. Now the next thing to do is to copy the vector A to your vector V. Now how should we do that? Again, the next thing to do is to copy the first vector starting from the head of the second vector. So we're just going to copy this vector to the head of your second vector. So let's try to do it. Just copy your A vector, which is like D. Okay, the next thing to do is also copy this vector starting from the head of your first vector. So we should do like this one. So that is why it is called parallelogram method, because we're actually going to have a parallelogram. Now how about our resultant vector? Now for our resultant vector, we are just going simply to draw a straight line from your central axis to the intersection or point of intersection of your copied vectors. So this should be our resultant vector. And we know that this is your x-axis and your y-axis. Now I want you to remember that parallelogram method is only applicable when we do have two vectors. But when we have three or more vectors, parallelogram method is not applicable. And we can only do the head to tail method. Now let's try to have another example. Now what if our vector A is somehow like this and your vector B is somehow like this one? Now how should we do that? Now first thing to do is also using your head to tail method is to draw your first vector, which is your vector A, from your central axis. So let's try to do that. Now this should be our first or your A vector. Now because this is a head to tail method, we're just going to draw the second vector starting from the head of your first vector. Now let's try to do that. Then this should be our second vector. Now how about the resultant vector? Again, for your resultant vector, just draw a straight line from the central axis to the head of your first vector. So this is how you do it. Now this will be our resultant vector, and we know that resultant vector is actually equal to A minus B, because your A here is directed to the positive side, which is your is, while your B here is actually negative because it is directed to south. Now I want you to remember, when your vector is directed to the north and east, they should have a positive sign. But when your vector is actually directed to the south and west, this should have a negative sign. Now let's try to have the parallelogram method. Now again, for your parallelogram method, first thing to do is to draw your first vector starting from the central axis. So this is how you do it. Now this is our A vector. Now second thing to do is to draw the second vector also starting from the central axis. So this second vector. Now again, we are just going to copy the first vector starting from the head of the second vector. So just copy the vector A. So this should be like this. Now second thing to do is to copy this vector starting from the head of the first vector. Now it should be like this one. Now again, for our resultant vector, we're just going to draw a straight line starting from your central axis to the point of intersection of the copied vectors. Now let's try to do it. Now this should be our resultant vector. And again, your resultant vector is actually equal to A minus B. Because again, your vector A is directed to the positive side, which is your is, and your vector B should be negative because it is directed to southwest. Let's try to have another example. Now what if we have your first vector like this one, and your second vector is actually like this one, and your second or third vector is actually like this one. Now how should we do it? Now we know that it has three vectors, so we can only do the head to tail method, and parallelogram method is not applicable for this one. Now let's try to do it. Again, your first thing to do is to draw your first vector starting from your central axis. Now it should be like this one. Now this should be your vector A. Now second thing to do is to draw your second vector starting from the head of the vector A. Let's try to remove this one first. Okay. Then we should draw the vector B like this one. Okay. Now we don't have more space. Now let's have some space before we continue this one. Okay, so we have copied or we have drawn the vector B. Now the next thing to do is to draw the vector C starting from the head of your vector B. So again, this is your vector B. Now let's just draw the third vector, which should be like this one. Now this should be our third vector. Now for our resultant vector, we're just going to draw a straight line starting from the central axis to the head of the last vector. Then it should be like this one. Now this will be our resultant vector. Now we should know that the resultant vector is actually equal to B plus C minus A. Why? Because our first vector, which is your A, is actually directed to the negative direction, which is your northwest, or from your west alone. Now your second vector is actually directed to the positive direction, which is going to north. Now for our third vector, it's also directed to the positive direction, which is in your northeast. So this will be our somehow formula for this one. Now let's try to have another example. Now what if we have vector A directed to this direction, vector B directed to this direction, and vector C directed to this direction, and vector D directed to this direction? How should we do that? First, let's have your Cartesian plane. Now first thing to do, of course, is to draw your first vector starting from your central axis. Now let's try to do it. Now this should be our vector A, and vector B is starting from the head of your vector A, so it should be like this one. It's too long, sorry. It should be like this one. And vector C, let's just try to draw this one starting from the head of vector B. Okay, let's just remove this one first. Okay, and for vector D, it's actually directed to this point, starting from the head of your vector C. Okay, this is your vector C and vector D. Now again, for our resultant vector, we're just going to draw a straight line starting from your central axis to your head of the last vector. So this should be our resultant vector, and we know that the resultant vector is actually equal to B minus A plus C plus D. Why? Because your A is actually directed to the negative direction because it is directed into the southwest, while your B is actually directed into the positive direction because it is directed into the north, and C is actually a negative one because it is directed to the southwest, and your D is also negative because it is directed to south. Now let's try to have another example. Now what if we have the vector A like this one, vector B like this one, or I'm sorry, like this one, vector C like this one, vector D is somehow like this one, and vector E is somehow like this one. Again, first thing to do is to draw your first vector starting from your central axis. So this should be our vector A. Now vector B starting from the head of your vector A should be like this one. Now vector C starting from the head of your vector B, it should be like this. Now vector D starting from the head of your vector C should be like this one also. Now for our vector E, it should be like this one, starting also from the head of your vector D. So this is your vector E and vector D. Now again, for our resultant vector, we're just going to draw a straight line from your central axis to your head of the last vector. So this should be our resultant vector. And the resultant vector is actually equal to C minus A plus B plus D plus E. Now we know that your first vector is actually in the negative direction because it is pointed to south or southeast. Your vector B is also a negative 1. Your C somehow is positive because it's directed northeast. Your D is actually negative also, and your E is negative also. So that is how you draw vectors graphically. Now what if we have a different values for your vectors? Now what if our vector A is somehow like this, 5 meters at east, and your vector B is actually 10 meters at 45 degrees north of east, and your vector C is actually 3 meters at 85 degrees south of west. How should we do that? Again, it has 3 vectors, so the only method that we can use is the head to tail. Now doing the first vector, of course we have already numerical values and also the direction. Now I want you to know that when you're going to graph this one, you should use ruler. And when you are going to use ruler, you should use scale. For example, 1 centimeter is equal to 1 meter, or 2 centimeters is actually equal to 1 meter. Somehow like that. But let's just pretend I have a ruler here. Now let's try to draw the first vector. We know that the first vector is directed to the east. So we should do like this one, starting from your central axis. Okay, pretend that this is actually 5 meters. So let's have your vector A like this one. And it is directed to the east direction. Now how about the second direction, which is your vector B? Now I want you to remember, to make it easier for you, is to always have a mini Cartesian plane drawn here. Okay, now we should know that the vector B should be drawn starting from the head of your vector A. Now how should we do that? Knowing that we have a 45 degrees angle here. Now using your protractor, I want you to measure 45 degrees. Now this is basically how you do it. For example, this is your Cartesian plane, and you have your protractor here. Now the idea behind here that whenever what direction comes first will be the direction of where you're going to count. For example, north of east. Now it actually has 45 degrees. Now starting from your east, you are going to count 45 degrees to north. So let's try to do that. You're going to count 45 degrees starting from the east going to north. So you should measure, or you should count like this one until you get the 45 degrees. Okay, and that's how you do it. So again, whatever direction comes first, that will be the direction of where you're going to count. And the last direction is actually the starting point of where you're going to count. So let's try to apply that. Now we know that this is our Cartesian plane here, and we have to draw 45 degrees north of east. So using your protractor, we are just going to count 45 degrees starting from your east going to north, because this is our north. Let's try to do that. Now because this is actually a 95 or 90 degrees angle, we're just going to draw like this one. And this is actually your vector B, and it has 45 degrees right here. And that is how we draw the second vector. Now how about the vector C? Again, I want you to draw a mini Cartesian plane here. And we know that we have the degrees here, which is actually 85 degrees south of west. So how should we measure this one? Now, starting from west, you are going to count 85 degrees to your south direction. So this is actually your west. So using your ruler, you're going to count 80 degrees starting from west going to south. So because it is 85 degrees, somehow it should be like this one. So we only have 3 meters, so it should be like this one. So this should be our third vector. Now for our resultant vector, we're just going to simply draw a straight line starting from your central axis to the head of the last vector. So this should be like this one. Okay. Let's try to remove some things here to better look at it. Now this should be our output. Your first vector from here, second vector from here with a 45 degrees angle, and your vector C from here with 85 degrees angle with your resultant vector here. Now we should know resultant is actually equals to A plus B minus C. Why? Because your A is actually directed to the positive direction because it goes east, and your B is actually directed to your north of east, which is actually a positive one, while your C is actually directed to your south of west, which is a negative one. So that is how we graph and how we add vectors using graphical method.